Hi everyone. For today's prototyping session, we'll be creating a visible encounter system, sometimes called a real-time overworld enemy system. This style of enemy encounters was made popular by games like Chrono Trigger and Earthbound. Let's not waste any time and just jump right into it. Alright, so we're working in the third-person template. I've go ahead and set up some prereqs here, so I have a player blueprint that can kind of move around and switch flipbooks, so nothing too crazy here. Let's go ahead and start off and create our enemy blueprint. So we can right click, select the blueprint class. This one we do have to choose of type pawn because we're going to be using a built-in movement component called floating pawn movement. These use AI controllers. AI controllers have to inherit either a pawn or a character. So in this case, we'll choose pawn. I'm going to call it BP_enemy. And then we can double click to open that up. And we can begin building out our components list for our enemy. I think starting off, we will of course have a flipbook. So a paper flipbook. And then select the paper flipbook so it's highlighted. We'll add another component called the capsule component. So it is a child of that paper flipbook. Go ahead and select the root component. So the BP_enemy self. Hit add again, and this time we will search for the sphere collision component. So the last thing we'll need is if we go back and we can select the root, hit add, and you can search for the floating pawn movement. Now we can go ahead and adjust some of these values here. I think starting off for the paper flipbook, I want to scale that by 5 because my sprites are a little bit small. And then for the capsule component, which is going to be inside of it, I'm going to adjust the capsule radius first to be 7, and then the half height to be 7. That's going to give us this kind of like little small sphere item here. And then once you have that set, we're going to go to the sphere collision, which is that outside, and that sphere radius I'm going to set to be 512. And then just for visuals, we can select our paper flipbook. I do have some examples. I can use my orc idle, so we can kind of see this is what our setup is going to look like. Now you'll notice we have two collision components. We're going to use the outer collision to drive the logic to move the enemy around. So when the player overlaps that, we can basically do some code. And then we're going to use the inner collider here to dictate when we move into our actual RPG style battle. Although we'll work on that on another video because this one's already going to be quite long. So let's go ahead and select the floating pawn movement. There's a few adjustments I'm going to make here. The max speed, I'm just going to do something like 300 so it doesn't move too quickly. And then for the planar movement, I am going to constrain to plane. And the plane constraint I'm going to select is going to be the Z-axis. Reason I'm doing that is I did not make these blueprints even to the player blueprint. And it's just me being lazy, but the player blueprint, I think it's like a little bit elevated. So because this one will be like zeroed out and the player is a little bit higher, it's going to move up. So you'll be able to see that. So we're just going to lock the Z-axis so you don't have to really worry about that. It'll just be an easy thing to deal with. One thing I want to do for this prototype too is I want to randomize these sprites. So I have 3 sprites and their corresponding flipbooks. So I want to randomly have it spawn and choose either an orc, skeleton, or a soldier. So we can do that in the construction script here. So what I'm going to do is I'm going to create a variable that I will call my animation selection, or anim selection. I'm going to use the data type of integer. I'll initialize it to 0, that's fine, because I'm going to hold the Alt key to bring out a setter. And then the way we're going to set this is we can pull off this and do a random integer in range. I'm going to start at the min of 0, and then the max is the total number of flipbooks that we're going to be using. In this case, I have 3, so it's going to be 2 because we start at 0. So 0, 1, 2. That's 3 items. And then after that, I can basically grab my paper flipbook, pull off this, and do a set flipbook. We'll hook up the execution pins like so. And then for the new flipbook, we can pull off and do what's called a select utility. And then I can use my animation selection as the wildcard index. You'll notice we only have 2 options, but I have 3 flipbooks. So I'm going to hit add pin. So I can add in another selection there. And then we'll just use the orc idle, skeleton idle, and then the soldier idle. And now if we go back to the viewport, you can see he's the orc. If I compile, he's a soldier. If I keep hitting compile, it can randomly just choose one of those things. So basically when we throw these things out in the world, it'll just randomly select one. So I think that'll be quite fun. Let's go ahead and begin coding this thing. So we got a lot of work to do. This will be a little bit of a longer one. I apologize. We're going to start. We're not going to use the actor begin overlap, so I can delete that. We're going to be doing a lot of work in tick, but we're going to save that for last, so we'll drag that down. Starting an event begin play, I need to do 2 things. We're going to be real heavy with the variables. I need a variable to track the rotation of the enemy. So I'm going to set that data type to be a rotator. I also need to track my enemy's location. So I'm going to create a vector called myLocation or myLoc. And then in the begin play, I can hold the Alt key, drag these 2 out, and get setters, and then just hook them up like so. Now we can use our default scene root because that is the parent of everything in this enemy blueprint. And I can do 2 things. I can get the world rotation, and I can pull off that and get the world location. The rotation goes into the rotator. The location goes into the vector. So if I hook this up like so, hopefully this makes sense. So then we can highlight everything, press C to comment, and this is our begin play. Next, the bit of code we can handle is going to be our overlap code. Now remember, we have 2 overlaps, but we're going to be driving most of this logic using the bigger sphere overlap. So we need to highlight that, and then in the event graph, when you have it highlighted, if you right click, you'll notice you have these context windows for functions and events. Under the events, there is a collision preset, and we have our begin and end overlap. We need both. So I'll start with the begin overlap, and then I'm going to select my sphere, go back and do my end overlap. So now I have both functions here, which is perfect. In both of these, I need to cast to my player blueprint. Again, I'm using the 3rd person character, so I'll cast to that. We grab the other actor, pass it in the object field like so. And then I need this player stored as a reference because I'm going to use it all over the place. So I can right click, promote it to a variable, call it whatever you want. I'm just going to use player reference. I also need to add another variable called the player location or player lock. And then I want to hold Alt, drag that in, and then I can grab off my player reference, get the world location. The player has several components, including a flipbook and a capsule component. I'm just going to use the capsule component. You can also use anything that's moving around with the player. But this makes the most sense to me, so I will grab that world location and I will pass it in like so. And then also need a variable to store a Boolean, and the Boolean is going to track if the enemy can see the player. If they overlap with the enemy's sphere collider, we're going to set the see player to be true. Once we see the player, the last thing we want to do is we want to set timer by function name. You could do event or function, it doesn't matter. In this example, I'm going to use function. I want to run a function every 0.1 seconds, and I want to loop it. And I'm doing this instead of using tick, just to kind of I guess, be a little bit lighter. Tick's very expensive, so you want to be careful with what you do in there if you can avoid it. So we'll just run this function fairly quickly, but definitely not as quick as you would if you ran it in Tick. We don't have a function created yet, so what we can do is under functions, you just hit the little plus sign, and I want this function to handle rotating the enemy either to its default rotation or to the player's location. So we can call this maybe our look at player function. So maybe look at player. Whatever you name it there, if we go back to the event graph, that's the function name that you have to put here. So look at player, just like that. Now we need a way to be able to start and stop and clear this timer. So it makes sense to right click, promote it to a variable, and we can call this just our look timer. And that'll come in handy in just a second. In the end overlap, we want to cast to our player blueprint, pass in the other actor into the object field, and then we want to set the see player to be false, because the enemy can no longer see it. It's ending the overlap. The player is leaving this big giant sphere, so the player has left. We also want to stop this timer because this is taking resources, so I can hold Control, get a getter, and then you could do this a few different ways. You could pause it, and then you'd also unpause it on the other thing, but I think it's just easier for this setup to do a clear and invalidate the timer, and then just reinstantiate the timer fresh when we kick this off again. And then after that, I want to call the look at player function to rotate the player or the enemy back to its default rotation. And then the last thing we'll need to do is we need to change the animation state for this enemy from running to idling. The way we can do that is we can create a new variable called our animation state, or anim state, not to be confused with our anim selection. So we'll hold the Alt key and we will set this to be a state of 0. We'll use 0 to represent idle and 1 to represent running. And then you can, of course, use this as your state machine. You can have as many numbers you want to handle all the different animation flows. It's a lot easier if you download, I think it's PaperZ Flipbook. There's an add-in for Unreal that allows you to use the animation blueprints for sprites, which natively I don't believe it does unless there was an update. It didn't in past versions, and I honestly haven't tried it in a bit. So we're going to make a simple one so we can control our animation states for the flipbooks. But all that is to say is this is all of our overlap code. So we can comment this and just call this our overlap code. So that's good. We still haven't created coded the function, but we'll kind of do that at the end. It's fine. We have some other custom events here, so we can do one called death. This one's easy. We'll just do destroy actor. So that one's pretty simple. We also need another custom event that we can call state machine. This one's a little bit trickier. This is going to be our state machine code. So we'll select state machine. You'll add an input that you can maybe just call state. And this will be an integer because we're using integers to control our animations. And then we can pull into a switch on integer. And then we'll just pass the state into the selection field. We can add, I'm just going to do 2 animation states because this video is already going to be super long. We'll do an idle and a run. So on 0, we can grab our flipbook. We can set flipbook. And then the flipbook we want to set is we need to use a select utility. The index that we're going to be using for that is our animation selection that we created in the construction script. Because remember, this could be a skeleton, could be an orc, could be a human. We don't know. So whatever it chose, we'll have to figure that out. So we'll hit the add pin and we will we have our orc, our skeleton, and our human. Whatever order you set here has to match the construction script. So you can see I'm orc, skeleton, soldier. So orc, skeleton, soldier. So perfect. So on the 0 case, we will set the flipbook to be one of the idols. And then we want to set our animation state to maybe something that's not tracked. So we'll do a default value of 99. And this is optional. You don't actually have to do this, but this is so, because we're gonna be doing some work in tick. This is basically, we can use this as a control so we don't execute an event call in tick that we don't need to. So it'll just save us a little bit of, not much headroom, but a little bit. And then what we can do is we can just duplicate this code here. Actually, we can duplicate this one as well. But instead of the idle, we're going to use the orc walk, the skeleton walk, and the soldier walk. So this is the idle phase, this is the walker running phase. Alright, so now we got death, we have our state machine. I think our state machine probably belongs by itself, so let's comment this and call this our state machine code. And we'll just drag this up a bit. Alright, we'll move tick down towards the bottom. We'll save that for last. And then I'm going to comment this to be our death code. And then we need another custom event. This will be one that we can call our update locations. So the player is going to be constantly moving. The enemy is going to be constantly moving. We need a way to update those variables that we have for my location and player location. The code's the same as it was in the begin play, so you can just hold Alt and get setters for player and my location. For the enemy's location, we were using the default scene root, and then we're just getting the world location from that, passing that in like so. For the player, we're getting the player's reference, so hold Control, and then you just need to get world location on one of the components of that player blueprint. So you can use, you know, the flipbook, the capsule component. I wouldn't use the camera boom because it's angled, or the fall camera. You could use the mesh, technically it's hidden. But I mean, honestly, capsule component probably makes the most sense. Everything is underneath that, so we'll drag this like so. Hook this in. All right, and I think that looks pretty good. All right, so that is our updating our locations. We need to figure out how to call that, but we'll do that later. We also need a way to be notified if the player is moving, because we don't have any easy way to check that right now. So we'll add another custom event that we can call movement tracking. We can add an input boolean that we can just say moving question mark, data type boolean. And then we could just use a branch condition. So B, click in the graph. We'll hook this in like so. We'll need another variable that we can call player moving question mark. And then what we'll do is we'll hold Alt, drag that in, Control D to duplicate it. And then if the player is moving, we'll set player moving to true. If they're not moving, we'll set it to false. And then we're going to come into another branch check. And then we're also going to check if the enemy can see the player. So if the player is moving, and the player's also inside this little sphere, this big old sphere right here, that means we can see them and that they're moving. So we'll want to set our animation state be 1. We're using 0 for idle and 1 for chase or walk or run, whatever. If it's false, we'll do nothing. Now, if the player is not moving, we'll set player moving to false, and then we'll set the animation state to the idle state, which in this case was 0. And then we can highlight all this, comment it, and this is our movement code. Everything that we use for our movement anyways. All right, and that is all the custom events that are kind of simple. Most of this work is actually being driven in event tick, so this is kind of the bigger part of it, but we pull off event tick into a branch node. The branch needs to check 2 things. We need to check if the enemy can see the player, and we also need to know if the player is moving. We can grab both these out and go into a AND boolean. It'll validate both are true before passing this check, which is exactly what we need. So if both of these are true, it'll then run the true logic. So basically, we want to set the state machine, and we can use the anim state that we've already populated beforehand. So we don't need to basically redo that logic. So once we set the correct flipbook, which in this case would be chase or walk, run, we need to then add some movement input to the actual enemy. And then after we move the enemy, we should probably update the location of our variables for the enemy and for the player. And remember, this is happening in tick, so this is happening very quickly. But how do we calculate that movement input? Well, it's just vector math. So what we can do is we already have our player's location, so we can grab that, and then we can grab our enemy's location, like so. And then what you can do is you can actually just subtract your player's location towards your enemy's location. And that vector is going to have 2 things. It's going to have a direction and a magnitude. The direction is, of course, you can think of it like an arrow between 2 coordinate points on a Cartesian graph. It lets you know the cardinal direction of the vector is going. The magnitude is the length of that arrow or the length of that line. Typically, with movement code, with players or enemies or AI, you don't really care about the magnitude. You generally only want the direction of the vector. The reason that becomes prevalent is if you don't ignore the magnitude, your enemy AI is going to move very quickly when they're very far away from the player. But as they get closer, they're going to slow down. And that's because you want to, if you don't want that to happen, then what you can do is you can normalize that vector, basically turn it between a value of 0 and 1. And that's generally what you're going to do for a lot of your movement code in any sort of like game development. So normalization of vectors is pretty common, so you'll probably see that again. All right, so now that we have our movement input, we need to handle the false pin. So I can pull into another branch check. And this one is just more, prevents me from doing extra work in tick. So this is kind of optional, you don't really have to do it, but I'm basically gonna take that anim state and I'm gonna check if it's equal to that, that specific value, 99 that we set. So if I know it's 99, I know I don't wanna do any work. So I wanna save myself a little bit of, so I'm not calling the event every time. So if it's true, I don't want to do anything. But if it's false, I want to update the state machine to be the idle. So I'll pass the anim state here. And then this is pretty much all the tick code actually. So we can comment this and call it our tick code. Okay, so we pretty much have almost everything done. We did forget to do our function, so near the top, we set a timer by function name called lookAtPlayer. If we go in here, we should probably code this thing, so I'm going to add a branch check. I just want to check if the enemy can see the player. And if they can, or if they can't, I'm going to do the similar thing of set the actor rotation. So I can press Control D to duplicate that because we're going to be rotating this thing no matter what. If I cannot see the player, I want to use my default rotation. If I can see the player, then I want to rotate towards the player. So how do we do that? Well, we can grab our default scene root from our enemy, and then we can get the world location from that. And then I can pull into a handy function called find lookAtRotation, which has a starting point, which is our enemy's starting point, and then it has a target point. The target point we can use is we have our player reference. So hold Control, drag that out. We need to get some component on that player blueprint, so I can get world location, and I'm going to use the capsule component again because I think that makes the most sense. And then I can split this because I really only care about the Z axis here, which is going to rotate the sprite to face the actual player. So if we compile, save, a lot of this isn't going to probably work because we haven't set up any of the code for in the player blueprint. So like if I start this here, we could see he rotates towards me, but that's about it. He doesn't walk or move. So, and he's also not switching animation states. So what we need to do is open our player blueprint. I'm using the third person template, so believe it or not, I'm using Mannequin. I just have Mannequin hidden, and I'm just showing the sprite flipbook, so nothing too fancy here. There's a few things we need to do. This hodgepodge is how I'm handling the movement of the flipbook. So this is overly complicated and it doesn't really need to be, but basically you can think of these 4 endpoints here as cardinal directions, like up, down, left, and right. And then this one down here is the idle not moving. So what we need to do is we need to notify the enemies when the player is moving. We can do that by getting all actors of a class. The class we can specify is the one we made. In this case, it was blueprint_enemy. And then we can come into what's called a for each loop. And then we have individual access to each item in that array, however many enemies are actually in the world at the time. And there's a handy function we can call called movement tracking that we made. That function has a Boolean that allows us to specify if the player is moving or not. I'm going to check it to true because the player is moving on these different endpoints here. So I can hook this and this and this and this here. So if the player is moving up, down, left, or right, I don't remember which way I set this up, but any of those directions will come into here. It'll notify every single enemy on screen by looping through them and calling that movement tracking and updating that Boolean value. Now similarly, we want to duplicate this down here, except we want to uncheck moving because this is going to be the idle. And then on the true pin here and on the false pin, I want to have a way to specify here that we update each of the enemies and let them know that, hey, the player is now idling. So they can update their animation states appropriately. And that's just me trying to, I probably didn't explain that earlier in the video, but Earthbound, the way they did their movement system is the enemies would only move when the player moved. So I'm just trying to replicate that basically. So that's why we're tracking that basically. The other thing we'll need to do is we need to start the battle or the encounter when the enemy overlaps with this little capsule component. So we can use this as a checker. So I can highlight this just like we did before, and I can right click. I can add a collision event called begin overlap. And this is kind of neat. Now, normally we would just simply cast to our BP enemy, and we can pass in the other actor field. And then this is always good to have, so we can promote this to a variable called our enemy reference. Oops, I forgot I already made one. So I used this file for another video, so we'll call this enemy reference 2. Ignore that other one. This one shouldn't have been here. And the reason this is useful is because on the finished battle, which we set up in a previous video, I can use that reference and call the death event that we just made. And this will actually destroy the actor when the battle is over, assuming the player won, of course. But you'll notice this doesn't do us any good because this checks the enemy, so it's going to fire as soon as this giant thing goes over. And that's not very intuitive. I don't want the battle to start when the player overlaps with this giant sphere. I want it to start when he overlaps with the tinier, smaller sphere. So this is a capsule collision component. So what I can do is I can come into another cast to capsule component, and then we can pass the other component list here into this object field. And then if this comes into a true evaluation, we can call random battle, and that will work. So now if we compile and save, I have my little orc, and if I move into his little sphere of influence, if I leave his little sphere, I'll go back. And now you notice the battle doesn't start, and he only moves when the player moves, which is great. That's what I wanted. And if he reaches me, the battle starts. Once the battle's finished, if I win, the battle ends, and the player's been destroyed. Now, another thing I wanted to call out is on the enemy blueprint, there's a lot of odd logic that you might have noticed. So for this one, if we just evaluated this here, well, let's do this. Let's set it back to the way it was. And then in the state machine, let's just call a print string that we can say updating state. So we compile and save. So you can see it called once, updating state in the top left. If I move, you can see it's calling for every time I actually move the player around, or if I actually enter in the field here, you can see it's calling like constantly here. And then if I stop, it kind of stops. So if we go in to that blueprint here, and I go over to this logic here, if we set this to skip this branch state here, and you don't check that, you'll notice it just constantly is hitting that event. So when you're working in Tick, you want to be real careful. It's usually fine if you're doing light stuff, but if you're doing any type of heavy computations, you'll want a way to check yourself out of it, so it's not doing a lot of heavy lifting. So otherwise, you can kind of overload, and you'll notice you'll get performance hits and all sorts of other things. So just be real careful with Tick, and just be aware of how it runs every frame basically. So it can get expensive quite fast. It's usually better to use timers. Timers are much more optimized for that. But all right, everyone, I think we'll cut the video here, but I hope you found some informative value that you can take into your own projects. But as always, thanks for watching, consider subscribing, and we'll see you on the next one.